So welcome back. This evening we're going to work with exponents. Exponents are very powerful because they can represent what we call repeated multiplication. Now before we get into exponents, I do want to go back a little bit and talk a little bit about repeated addition. Repeated addition can be modeled using multiplication, or vice versa. Multiplication can represent repeated addition. So when I look at this problem right here, notice how I have 9 plus 9 plus 9 plus 9 plus 9. Instead of trying to figure out as an addition problem, I could look at this as, well, that's 1, 2, 3, 4, 5 9s added together. So I'm allowed to rewrite this as 5 times 9. So in other words, 5 9s. 5 times 9. And now instead of having to count by 9s, I actually can just count by 5s. And we know that 5 9s, or actually 9 5s, would be easier to calculate. And that would be 45. So I can write repeated addition as multiplication, but sometimes multiplication is just a shortcut to calculate the problem. So here, if you look at this, I have 1, 2, 3, 4, 5, 6, 7 x's. But notice how they're added together. Repeated addition, we can use multiplication. Since there's 1, 2, 3, 4, 5, 6, 7 x's added together, I can write this as 7 times x. A lot of times, they'll just drop the parentheses and just write that as 7 x's. But remember, 7 x's means 7 x's added together. A little bit different. So 5 times 2, we know 5 times 2 is 10, but also don't forget that this could mean 5 2's added together. That could mean 2 plus 2 plus 2 plus 2 plus 2. So there's another way to write it. So I can write that as 2, 4, 6, 8, 10, or we just know that 5 times 2 is 10. When it comes to 6 times y, don't forget that 6 times y could also mean 6 y's added together. So it's all about learning your vocabulary and what this actually can be interpreted as. So 6y can be modeled as repeated addition. So these both mean the same thing. A lot of times in my head, that's what I'll actually picture in my head as a bunch of y's added together. Now, if I look at exponents, exponents can be used to model multiplication. So when I see 5 times 5, notice how this is repeated multiplication? That's what we're talking about. Exponents go with repeated multiplication. 5 times 5 can also be written as 5 raised to the second power. That little 2 is called the exponent. A lot of times, the 5 in this case is called the base. And we a lot of times read this as 5 squared. So when I look at 5 times 5, 5 times 5 could be 5 to the second power. So again, powers are synonyms for exponents. So instead of saying exponent, another common word there is I could say power. And again, 5 to the second power basically is commonly read as 5 squared. So anytime you see an exponent of 2, that usually just means it's squared. Here I have 2 times 2 times 2. 2 times 2 times 2 is the same thing as 2 to the third power. Notice again how this is repeated multiplication. Repeated multiplication, I'm allowed to use exponents to denote that. Gives us a shortcut. Again, we have those keys on the calculators as well that we want to take advantage of. And again, 2 to the third power is most commonly referred to as 2 cubed. 2 cubed. So like an ice cube, 2 cubed. So cubed a lot of times is associated with the power of 3. Squared is a lot of times associated with that power of 2. Those are the most common exponents that we deal with, is the squares and the cubes. But there are other exponents. For instance, m times 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 m. Since that's repeated multiplication, we can use an exponent for that. We can say it's m to the 1, 2, 3, 4, 5, 6, 7, 8th. So m to the 8th power. And again, there's no special word for that. When you get to those exponents like 4s and 5s and 6s, we just simply say to that power. So in this case, m to the 8th power is how we would read that. So when I look at this, most commonly we read this as 10 to the 5th power. So we don't usually use the word exponent most commonly we probably use the word power. So 10 to the 5th power, what does that mean? Well, it just means 10 times 10 times 10 times 10 times 10. And we know that 10 tens is 100, 100 tens is 1,000, 1,000 tens is 10,000, and 10,000 tens is 100,000. So let's see here, 100, 1,000, I mean I got it, 1, 2, 3, 4, 5. So we should have 100,000 there. What's cool with base 10s, that 5 really just tells you how many zeros to stick on there. That's kind of our shortcut. So anytime your base is a 10, that 5 just tells you how many zeros to stick on it. That's kind of our shortcut with that. Because you multiply by 10, you're essentially just going to be adding a 0. That's kind of what we learned. So 7 squared would be the same thing as 7 times 7, which would also be the same thing as 49. So those are all equivalent expressions, written in different forms. This is in exponential form, this is in multiplication form, and this is just worked out, evaluated. I do have 2 more examples I want to look at. This here is, a lot of us would want to say negative 2 to the 4th power. This actually means the opposite of 2 to the 4th power. So in this case, the 4 only has power over 2, not the negative, which means there's 4 2's, but there's only 1 negative. So in this problem here, there's only 1 negative, but there's 4 2's. And we know that 2 times 2 is 4, times 2 is 8, times 2 is 16. But since there's only 1 negative, we know that answer just stays as a negative then. So 1 negative, we'll flip it back to a negative. Now over here, notice how this negative 2 is in parentheses. So, especially when you put things into a calculator with negative numbers, those parentheses are going to matter a lot. So negative 2 to the 4th power actually means negative 2 times negative 2 times negative 2 times negative 2. And we know that, well, 2 times 2 times 2 times 2 is 16. And we have 1, 2, 3, 4 negatives. So since there's an even number of negatives, and you're multiplying, that's going to make a positive 16. So it kind of goes negative, flips back to a positive, flips back to a negative, flips back to a positive. So it's just like a light switch when you're multiplying with negatives. So since we have an even number of negatives, we will make that a positive 16. Okay? So it's really important to pick up on the difference between repeated addition and repeated multiplication. Repeated addition, we have examples like this. Repeated multiplication, we have examples like that. So again, watch that for those 2. Those are confusing. Stay tuned.